Hello everyone. Last class we learned about law of conservation of momentum. So today's class we will solve some problems related to law of conservation of momentum concept. So let me take a problem. A bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? So the situation is like that. So let's take a pistol. So this is a pistol. Let me take it properly. So this pistol contains a bullet, and the bullet is fired, and they are given the velocity of the bullet. So what happens after firing? After firing, the bullet moves forward and the pistol moves backwards. So that we call as recoil velocity. Now, this is before firing and this is after firing. After firing, what happens? The pistol will move backward. So that velocity we known as recoil velocity. This is due to because of Newton's third law. When bullet moves forward direction, so this is action because of the fire, and there is a recoil force which acts on the pistol in this case. So due to because of that force, the pistol moves backward direction. So we need to calculate what is the recoil force in this case, recoil velocity of the given pistol. So for that, we need to apply law of conservation of momentum. Suppose if I keep these two figures at here, so what do you remember law of conservation of momentum? So total momentum before collisions. Let me take it down so that I can get space. So according to law of conservation of momentum, total momentum before collision is equal to total momentum after collision. So if I write the formula at the side at here, so if you remember that we have taken as m1 u1 plus m2 u2. So this is the total momentum before collision, which equal to total momentum after collision m1 v1 plus m2 v2. So this is the total momentum after collision. This is after collision, this is before collision. Now we need to find each term at here. Let mass of pistol, let mass of pistol which is given in the problem, so it is 2 kg, so it is supposed to be O. Let mass of pistol m1 equal to is 2 kg, and mass of bullet m2 is equal to given 20 grams. If you convert these grams in terms of kg, so if I write like this, 1000 grams equal to 1 kg. So therefore 1 gram equal to 1 upon 1000 kg. So in the place of grams, I can substitute that 1 upon 1000. so I can get that 20 upon 1000 kg. So if you can do that calculation at here, so this it will be end up with 0.02 kg. So that is the mass M2, 0.02 kg, mass of bullet. Now before firing the bullet is also which is present inside the gun. So the bullet velocity is 0 and gun velocity also 0. So before firing velocity of pistol, that is I can take u1 equal to 0 and velocity of bullet, that we take that u2 equal to 0. So this is the condition what we are talking about before firing. So if the velocity of the pistol equal to 0, what about momentum? Momentum, I can write that down. Momentum of pistol. Momentum of pistol. So that formula m1 u1 is equal to 0 because u1 is 0. And similarly we can write that what is the momentum of bullet. Momentum of bullet, that is m2 u2 is equal to 0. How it is 0? So let me write it at clear. So because m1 u1, so we know that mass of bullet equal to 2 kg, but the u1 value equal to 0, so its value becomes 0. Similarly for the bullet, so it's m2 0.02 kg, but velocity equal to 0, so its momentum equal to 0. So this is the momentum values. Now we need to write the total momentum before firing. So total momentum, this everything is before firing only. Total momentum before firing is equal to m1 u1 plus m2 u2. So that 2 we got as 0 plus 0 is equal to 0. So therefore total momentum before firing equal to 0. Okay, so this is we needed. So let me highlight this one, total momentum before firing. Now let me take this as equation 1. Now let's comes to after firing. So this is the situation before firing. Now when it comes to after firing, so after firing the mass of bullet do not change in the given situation, and the mass of pistol also do not change. They both remain same. 2 kg is the mass of pistol and 0.02 is the mass of bullet. But bullet have velocity 150 meter per second, but we need to find the velocity of the recoil pistol. So let me write that first. After firing, So this is the case after firing. Now after firing, mass of mass of pistol, which is m1 equal to 2 kg, and mass of bullet and m2, which also equal to 0.02 kg, and velocity of the, so this is velocity. So let me write the velocity of the pistol. Therefore, velocity of the pistol. So this one we need to calculate. So let me take that v1 is equal to how much, and velocity of bullet. So let me take that v2. So that's given that 150 meter per second. So now if you have mass and velocity, let me calculate the momentum. Momentum of the pistol. So that equal to m1 v1. We don't know that. We need to calculate that, which equal to 2 kg. Suppose let me take this velocity v1 as v. So 2 kg times v is the momentum of the pistol and momentum of the bullet. So m2 v2. So this you can multiply 0.02 kg times 150 meter per second. So this you can take as a let consider. Now what shall we do? We need to apply the law of conservation of momentum. So these are the values we need to use. m1 u1 equal to 2 kg times v, and m2 v2 equal to m2 v2 equal to 0.02 kg times 150. Now applying by law of conservation of momentum, by law of conservation of momentum, apply the formula m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So that is momentum, total momentum before collision equal to total momentum after collision. So we got the values m1 u1 and m2 u2. So this total momentum value goes to 0. So that value you can substitute here. So 0, which equal to m1 v1. Here I have m1 v1, that equal to 2 kg times v plus m2 v2 0.02 kg times 150 meter per second. Now let's simplify this. Now I can write this for a moment. I will remove these units so that don't make us confused. So if you remove the units, so this is what looks like. Very simple expression, 0.02 times 150. So therefore you can bring one of the term to this side. So you can get that minus 2v. I bring this term to this side, which equal to 0.02 times 150. So find the v. So v equal to minus, send this everything that side, minus 0.02 times 150 upon 2. Now you can cut this. So 0.01 times 150. So if we can multiply that, velocity v equal to, so here I can get minus 0.01 of 150. So if we can multiply that, we can get that 0.01 times 10. So if we can multiply that, I can get minus 1.5 velocity meter per second. So this v, what we taken, so this is the v is the velocity of the piston. So this is the recoil velocity of the piston. So therefore, finally we can write the recoil velocity of the piston. The recoil velocity of the piston v equal to minus 1.5 meter per second. So here negative sign shows what? The minus sign tells about the piston is moving backwards when bullet is moving forward. So that we can understand from the figure. So if you can observe the figure carefully, so in this figure, the bullet is moving in the forward direction. Now this is the velocity of the bullet, which is moving forward direction. Or for your understanding, if I consider this as an x-axis, so this is positive x-axis and this will becomes negative x-axis. Now when bullet is moving in the forward direction, so with velocity of 150 meter per second, the pistol is moving backward direction. So the minus sign tells about the direction of the gun, which is moving the opposite to the direction of the bullet. So this is how we apply the law of conservation of momentum to find the recoil velocity of the bullet. Let's try to solve one more problem. Same model problem. From a rifle of mass 4 kg, a bullet of mass 50 grams is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. Same thing, here we need to find the recoil velocity of the rifle. We will apply the same law of conservation of momentum formula here. So let me write the formula. You remember that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now let mass of rifle m1 equal to, given that 4 kg, and mass of bullet m2 equal to 50 gram. So we can convert this 50 grams in terms of kg. 50 upon 1000 kg, so this becomes 0.05 kg. So that is the mass of bullet. and before firing, velocity of the velocity of the rifle. So let me take that u1 equal to 0 because the bullet is not fired, so there is no recoil force. Similarly, velocity of the bullet and u2, that is also goes to 0. So if the velocity equal to 0, then what about momentum? You can write that momentum of the rifle. Momentum of the rifle, momentum formula m1u1, so its value goes to 0. m1u1, that implies m1 equal to 4 kg and u1 times 0, the momentum equal to 0. Therefore momentum of the bullet, that equal to m2 u2. So momentum value 0.05 kg times 0, that will give 0. So because in the before firing, the bullet also at rest. Now we can write that total momentum before firing, that equal to m1 u1 plus m2 u2. Now you can substitute that value at here, which is equal to 0 plus 0, the total momentum goes to 0. So let me take this as equation 1, I can use it later. So total momentum before firing, how much it is? Equal to 0. Now we need to calculate for after firing. So this is before firing. Let me take now after firing. After firing, mass of bullet do not change and mass of rifle also do not change. So what will be the change in the velocity of the rifle? So velocity of the rifle, let me take that v1 equal to as v, this we can let. Now velocity of the bullet, let me v2, so the velocity of the bullet is given that 35 meter per second. So velocity of the bullet value is given 35 meter per second. Now if you know the velocity, let us try to calculate the momentum. Therefore momentum of, let me take another color, momentum of the rifle, value formula m1v1. So m1 value is 4 kg and v1 I have taken as v. Now similarly, momentum of the bullet, that equal to m2v2. So mass of the bullet 0.05 kg and velocity of the bullet 35 meter per second. Now we need to calculate the total momentum after firing. Total momentum after firing that equal to m1 v1 plus m2 v2. So m1 value 4 and v1 value as v I have taken, plus m2 mass of bullet 0.05 and velocity 35. Now by law of conservation of momentum, momentum before collision, total momentum before collision, or here no collision, we can take that as firing. Total momentum before firing equal to total momentum after firing. Total momentum after firing. So we got that before firing total momentum value equal to 0. So I can substitute that as total momentum before collision, before firing equal to 0, and which equal to, what's the value for the total momentum after firing? Is equal to 4 times v plus 0.05 times 35. So let us solve this. So if we can multiply that, 0 equal to 4v plus, so 35 times 0.05. So this value I get that 1.75. So if I write 4v equal to minus 1.75, therefore v equal to minus 1.75 upon 4. So if we cut this value at here, so this gives to me 0.4375. Therefore v equal to minus 0.4375. So here v is nothing but the recoil velocity of the gun. The recoil velocity of the rifle, v equal to minus 0.4375. So here minus sign tells about the rifle is moving backward direction.